Hello everyone and welcome back to another Universe Sandbox video, and today we're going to be doing another episode of evolving a custom system from birth to death. So we're on part 2 of this series for today's video, and without further ado we're just going to hop straight into this. So if you remember last episode, we set up the system, we formed it, we had a lot of formation stuff, lots of orbits being ejected. I mean, the system's still kind of sorting itself out in the outer reaches of all of these other gas giants and dwarf planets and stuff, so we are going to run the system for a lot of time today. We also had a brown dwarf on the edges here, and we also have some dwarf planets already having similar sort of orbits to Sedna and Planet 9 in our own solar system and stuff, with all these weird elliptical orbits. So hopefully we'll see more stuff like that today, which will be pretty cool. But yeah, we're going to evolve the system up, probably evolve the star itself. And actually mentioning the star, just go into the comments. One of you guys in the comments, user Total Anarchy, he said here, and this is actually quite a good point, since the star we've made is a lot more massive and luminous than the sun already, that means it's going to have a different life cycle. And yeah, that is a very, very fair point. Can't argue with that at all. So it's got more mass. It's going to burn through its hydrogen fuel quicker. So it's going to go for a red giant and a red supergiant phase. So this thing's going to get pretty big. So this is going to be cool. And he also mentioned as well the planets that could possibly support life. They're kind of be almost like Mars in our own system, possibly, where they're not going to be able to support life for a very long amount of time due to this star. It's going to be getting a lot brighter quicker than our own sun and stuff. So yeah, he made an example here, 100 to 200 million years with how luminous his star's getting. So hopefully we'll see the Earth-like world here in its current state. It's obviously too cold, so it's almost like a Mars sort of preset at the moment. But maybe once the star gets brighter and warmer, this will have some possible life likelihood stat going on it. I mean, at the moment it's a little too cold. I mean, yeah, it's roughly Mars temperature at the moment. So when this star gets brighter, we may see this planet have a little sweet haven for a while until we make the star too luminous. So yeah, well, enough of me talking. Let's actually continue on. So what we're going to do is we're going to run the system fairly quick here. I don't want to go too fast, but I want to see more of these outer orbits change, because we're still in the fairly early days of the system here, I'd say. I mean, the system's still kind of sorting itself out. A lot of the gas giants are in here. Let's just get a quick lineup of all the objects as well. So also we have our largest gas giant, which is Akam here. We have the brown dwarf. We've got all the other gas giants going with like nice gassy colours, nothing too extraordinary look. And I think someone said one of the objects looked like Planet 9. But yeah, we've got a nice load of our icy giants. Also we've got the inner planets. We've got some of the crazy cloud ones, some nice modded ones closer to the star. So yeah, a nice list of all different types of object here. So, and we got, remember, blue here. This was a pretty exotic one. It's almost like Titan, but obviously a blue version of it. So that was a pretty cool one. We also have Orion, which was ultra reflective. Maybe this will turn out being a Venus-like world. We could, in theory, do that, given it a stronger atmosphere. So yeah, that'd be pretty cool. So yeah, we could actually do that right now. Let's actually modify. Let's actually have a little. I want this thing's atmosphere to be really, really sort of heavy, nasty, sort of Venus levels of atmosphere. So has a very high albedo, so we're going to lower that a bit. Also, it's still going to be very reflective, but the ATM, I want this thing to be going up to roughly 82. I mean, that's fairly close to a Venus level, so that should hopefully warm it up a bit. So let's just click play. Obviously, we're going to look back onto the star, and let's just let the simulation run for a bit, because obviously some of these orbits aren't going to hold on. We're going to see some ejections probably here, and I'm hoping that one of the gas giants kind of gets ejected as well. Oh, looks like we're on a bit of a lag spike there. Something's definitely going on. But yeah, we have obviously, I think we had 6 gas giants, wasn't it? So we have 1, 2, 3, 4, 5, 6. Yeah, we've got 6 gas giants. So in theory, when we did our own solar systems test, the solar system could only support 4 gas giants. As we saw, the 5th gas giant would never work. This one has 6. So in theory, there should be a gas giant that will get ejected at some point, possibly. So let's just keep running this. We don't want to go too fast, because obviously that inner solar system, I don't want anything going too crazy in there. But we can see some of the orbits in there. I mean, it's a little wobbly going on in the inner system, because there is quite a lot of stuff in there as well. But as we can see, yeah, I'm not expecting much from this object, I have to say. I think this one may be tossed out completely. Judging by that orbit, I mean, that's going on pretty much forever. So that, in theory, could have already been... That's maybe gone already. How's our brown dwarf doing? Let's have a little look in the little mini system. So we can see the orbits here are still sort of working themselves out. I think we had one gas-like object around it. Yeah, we had like a Neptune-like world around there. Oh, another lag spike. So yes, that lag spike's almost like something's going on. The brown dwarf orbit, that's fairly consistent out there. Let's just keep it running. Go a little quicker. I really want to see some orbit changes. Oh, so we just saw something from the brown dwarf. I'm sure something just happened there. I think something broke away. I'm expecting that this object here, this one's going in and out of the gas giant area. So I'm expecting, we can see it's being affected by the brown dwarf's presence as well. So it's now got an orbit sort of going in the inner, outer areas. We can see the brown dwarf is still having an influence on some of these objects as well. So this is going pretty interesting so far. But yeah, that outer system is definitely not going to work forever. That big Akam gas giant here, the largest one, 1.2 Jupiters. That's going to have a serious effect if something gets too close to it. And we can see at this orbit here, Taskhurst, this one's orbit is going fairly close in between those gas giant orbits. So it should be interesting to see if this thing eventually gets tossed out. So, you can see it's a pretty extraordinary orbit it's got going on there. So, I mean, the brown dwarf could still have influence on it. This red object here as well, Ideal, this one here, it's actually had an atmosphere at spawn with it, if we remember right. So, yeah, that one's getting influence. So we can see more objects, all of the little dwarf planets, all of the rocky sort of objects further out. Yeah, they're not looking too good. And yeah, look at the orbit of this one now. Let's just slow it down and just watch this thing as it goes in to the star. This thing is, in theory, almost the closest planet in the system. Let's see how close it gets here. I mean, it's going all the way into the inner solar system, coming in very fast. That could upset some of the orbits. But yeah, that thing, that does get pretty close to the star at some point. I mean, yeah, look at that. So that could really affect its temperature when it gets that close to the star. But yeah, eventually this could just get a massive propulsion from the star, a massive slingshot, and it could just get rid of it completely. So let's see how we're doing. This object's completely gone, so we're just going to get rid of that so it doesn't keep bugging us out. We've got 2 Sedna-like object orbits out here now, so they're getting pretty extreme. But yeah, I'm not expecting much from this Taskhurst object. I think that is going to be tossed out. Judging by that orbit, I mean, I'm not seeing much possibility of this one surviving much longer. Or we can see the brown dwarf has just stolen one of the gas giants from the star here. Look at this. Just set up a little binary with that. Now that's interesting. Because this could make the brown, in theory, this could eventually propel one of these objects completely out of the system here. So we can see the brown dwarfs. You see, look, now the star is breaking away again. Yes, see, now one of these gas giants is now got a peculiar orbit. And what do you know? It's the one that looks like Planet 9. So maybe like our own solar system, maybe the 5th gas giant, or this one representing Planet 9 almost, maybe this one will have a similar fate to just being tossed out, thrown really, really far out the system. I mean, that brown dwarf obviously can have an effect on it as well. But yeah, this gas giant, not looking too good for it now, is it? I mean, yeah, we can see that's going to break in between the first. So we've got Salby over here, which is one of the common names that you always get. So that's one of the normal gas giants. When we've got the biggest gas giant there. But now this blue one's orbit is going in between those 2 gas giants in the inner areas of the outer solar system here. So in theory, this one could be meeting a bad fate. It could be the end of the line for this one if it doesn't get out of that area, because that's not looking good. So it looks like the this gas giant over here, this bluer coloured one, this one looks like it's doing all right. And I think Fitziness here, those 2 seem to be doing okay. But yeah, this one here, it's not looking good. So in theory, this is the 5th gas giant, because the 6th gas giant is actually around the brown dwarf. So there's actually only 5 orbs in the star. It looks like it's actually been broken away from, yeah, it's still having interactions with that brown dwarf. It's really going to upset its orbit eventually. So this is interesting stuff. I'm still surprised that this Taskhurst orbit is still going in there. I mean, it is breaking in that inner solar system fairly quickly here. So let's just keep it rolling a bit. I want to just get it a little quicker. And actually, what I'll do as well, we will throw a save in just in case anything goes horribly wrong. So we'll just put it as 5.0 now. So we've got a save of a newer version of it. And then we'll just keep it rolling. So let's keep that. Click play. Let's see how our system evolves. So we can see that brown dwarf. It looks like this Ideal object's orbit has now been really, really upset. And now that's also got a Sedna orbit. So interesting. So another dwarf planet-like object. Well, I say dwarf planet. This thing is actually fairly large. 2.37 moons. So that is another Earth, or another planet, I should say. It's been kind of tossed out there. We can see it, the 5th gas giant representer here. This one is now further out than the brown dwarf. So we can almost see a Planet 9 is sort of being set up here as a very, very outer object. But that brown dwarf is still going to have effects on it at that distance, because its orbit is still crossing over where that brown dwarf is sitting. So yeah, we've almost got like a little mini Planet 9. We've got like a Sedna orbits going on here. So we can see some similar sort of similarities. There's Taskhurst here. So this one is now, that one's now being eventually just been tossed up. Seems like that 5th gas giant is still having a huge problem getting thrown around the system. I mean, look at that. It's just being pulled all over the place with the presence of the brown dwarf, the other gas giants closer in the system. That is pretty hectic stuff. Oh, look how Earth-like. I didn't even realise we selected him, actually. So he's still just chilling in there. But yeah, this one is not, it's not looking good for this one, is it? That is not looking good. So let's just keep it rolling. Let's look back onto the main star. Maybe what we should do as well is going to evolve our star a bit. Let's make it a little brighter. So we'll go to 1.25. So a little 10% sort of sun increase there. Oh, right. Okay. Oh, we can see a real Planet 9 orbit being set up now. Look at that. It's really, really trying to break away. That is not looking good. Yeah, that is really, really getting similar to our own solar system with the way these are working. We've got the Sedna orbits. Yeah, we've got like a Planet 9 sort of object out here now. Not looking good, really, is it? I mean, there's a lot of Yeah, I mean, some of these objects are probably going to completely go. What's that? So we've got this task cluster world is still trying to have interactions with the inner solar system here. Looks like another object's also having an effect. So this other rocky world here, that one's probably going to get tossed out because it's crossing right where Akam is, which is the big gas giant. Or we can see it, Tash Curse has just been tossed out again there. Oh, dearie me, this is hectic. This is very hectic. So, still running the system. How's the inner solar system doing? The inner solar system's looking fairly comfortable in there for the time being, so that's all fine. So, all the objects further out than Akam, really, are having constant changes. But Salby here, this one's doing all right. Akam, they're doing okay. But everyone further out than that is having constant sort of changes. So we can even see it like the Uranus and Neptune sort of, or the planets representing Uranus and Neptune. So, for instance, this would be the Uranus, the Neptune would be the sort of bluer one here. So, kind of match up the colours with those. So, pretty hectic stuff here. But in this system, in theory, the object representing Saturn, which would be this one, this is actually closer than our Jupiter-like object. So, slightly change, but yeah, we're getting some similar sort of results of our own solar system with the way this is sort of spawning in here and rolling out. So, how are we doing that? Where is this? This one is just all over the place. Right. So, let's keep it going here. Trying to speed it up a little quicker. But yeah, these orbits are going very crazy, aren't they? Wow-wee. That's actually, how is our Earth-like doing? Because we did increase the luminosity, so it's still getting, yeah, it's still fairly cold here. That star does need to evolve up a bit more. How's the inner solar system doing planet-wise? So we can see at LP12, 50 degrees. I mean, it's, what is all that about? I mean, that's weird how it's looking there. We've got Fermia here. This was obviously one of the hotter ones. It's a 14. Or it's only 15, actually. It's not doing too bad right now, so that one's doing okay. The next world out was the Sulfur gas dwarf. Obviously, it's a gas dwarf. It's not really too much to look out there other than the clouds. Then we had Earth-like, Orion. This was the one we gave it a pretty crazy ATM. It hasn't really worked itself out yet, so maybe we'll try and give it a little more. Let's see here. We could try and give it, could lower down that reflectiveness. So make it absorb more light. Maybe hopefully that'll warm it up. Looks like it has actually affected it slightly there. Right, so back to the outer system. Oh my god, this is crazy, right? So we can see it, we can pretty much work out that some of these have just completely had it now. The orbits are all going all in different directions. This is very extreme stuff here. So let's keep it going. The brown dwarf has had an interaction with Ideal here, which is that red one. So that one is not looking too good for that one. We got the Planet 9 object coming in again. Oh, wow, that brown dwarf being out there is really sort of upsetting the outer system, surprise, as well. So, no, but the brown dwarf is, let's go to its mass quickly. It's 1.23 Jupiters, so yeah, it's fairly about the same size as Akam here for mass. That's 1.27, so that's still slightly larger in mass. So pretty crazy stuff there. Oh, another little lag spike. Anything going on there? So we can see it. It looks like Tash Curse has finally met the end of the line. That's going to be ejected. This one as well looks like they're. I think we can pretty much argue all of those are pretty much going at this point. So let's keep it rolling. Trying to speed up as quick as possible. Oh, dearie me, right? So so now the fifth going again is now back. It's still having, no, it's out again. It's still having interactions here. Is that, maybe that's done it though? Is it going to come back from that? I mean, that orbit is, god, that is very hectic stuff. Very unstable. We can see Idel here has been ejected pretty much as well at this point. So, how are we doing here? Still try and run it as quick as possible. But yeah, okay, so this one's definitely gone as well. I think Fawn over here, I mean, that's not really in orbit anymore. Let's just get rid of that. And maybe possibly Idel here as well. It's not really hanging on too well. So, how are we doing again? So the inner solar system's still doing fairly okay. I'm just really surprised that this object here is still, its orbit is still cutting in all of those gas giants. It's not being affected too much. I'm very surprised that that hasn't been tossed out yet. I mean, eventually it's going to go. There's no way that's going to sit there for the rest of time. I don't think that is definitely going to have some sort of interaction with one of the gas giants in that part of the system here. So let's just keep watching. A little further out, so we can. Yeah, this is very crazy stuff indeed. Right, let's try and go a little quicker. Don't want to go too fast though, but let's really get it going now. So the inner system's all right. Outer system. So the brown dwarf out there, that's fairly sitting nice and comfortable there. I don't think we're going to see any change of that now. And actually, speaking of the brown dwarf, how are the objects around the brown dwarf doing themselves? We can see, yeah, they're fairly sitting okay. We do have the sixth gas giant is sitting around the brown dwarf at the moment, so that's doing okay. They're all fine in their little miniature system there. Back to the star itself. Not Akam, let's go back to the star. I think it's time to re-evolve the star a bit more, so let's double that up to... Oh, so because the habitable zone has just had a boost there, so we've times it by 2. So in theory, we could start seeing some temperature arise at some of these, so... Pretty crazy. How's Fermia doing? 70. I want to give this one I think should have a higher atmosphere. What was it before? Let's give it a little increase. This one's at 95. Really? Wow. That should, in theory, be a lot higher than it is, I think. So I don't know what that's all about. It's quite a large object, this one. 0.82. That's a huge. 268 Earths. Rocky planet there. Right. Okay. Right, so let's see how Earth-like's doing. Have we got any temperature here? So we can see it's had a little increase. So we've got minus 39, 38. So it's still, still sort of sorting itself out for the time being there. But that is probably the best-looking world for the Earth-like stuff. How's Orion doing? Still getting, still too cold there at the moment. I'm real surprised that this object here has managed to last how long it's had, really. I mean, that is really sort of cutting in with all those gas giant orbits. How is it still hanging on? That is very interesting stuff, because we saw the other... Yes, orbit is being affected. I reckon the brown dwarf could pick that up eventually. If it gets in the wrong... See, there we go. Yeah, there we go. So the brown dwarf has just had a massive impact on it and has changed its long-term orbit of going in and out of the solar system. If that brown dwarf's going to keep picking it up eventually. We can see if they get too close again. Oh, the fifth gas giant had it. Oh, so there we go. So that one has just been completely... That may have just completely killed it. Going all the way out there. That may have had it. So there we go. So now we can see it. The system's kind of sorted itself out. If we just look in this sort of area, the brown dwarf's obviously the last object orbiting the star normally. And then you've got the rest of the objects all sitting in here. It looks like Aurapax, the only rocky object left in the outer system for the time being. But maybe that one will get changed eventually. But yeah, pretty crazy stuff. Oh my, right. Yeah, I think that's the end of the line, unfortunately. It was sitting there for a while, but it's just completely had it. Fifth gas giant here, still uncertain on its fate over there, really, as well. So, pretty hectic stuff indeed. And actually, what we'll do as well, since we've had some more changes, we'll put this to 6.0 now and get another save in, just in case something goes completely crazy. So, we can see that the orbits have really cleaned themselves out since we started this video already. So, interesting stuff. That's all sorting itself out here. Star... Let's give you another booster. So luminosity getting brighter, getting older. So how are we looking now? I think LP12 here is going to start really seeing it now. Yeah, we can see 200 degrees there. That's a big increase. Fermia, 158. Sulfur gas dwarf, probably going to see 7 degrees there. Earth-like, how are you doing? 38. Okay, so, right. What we'll do is we'll quickly just lower that down a bit. So we'll go back to around 4, 5 maybe. I want to see if we can get the Earth-like world at a stable sort of condition. So let's slow that down. Oh, we're going too quickly there. Right, let's calm down. There you go. Okay. Oh, what's that orbit at the moment? Oh, that's just one of the dwarf ones. Okay, so 32 degrees. I think maybe if we maybe lower the star a bit more, just to try and get that sweet spot of where the Earth-like world would actually finally be habitable at this point. So 0 degrees, it's warming up. Okay, so this is the point where we would eventually try and get this one to lifelike conditions. So obviously very, very cold, but we can hopefully press the melt button nice and easy. No, the melt button doesn't work. Oh, dearie me. Right, so maybe we just plus and minus the water a bit, let it sort itself out. But yeah, in theory, this is the point in this system's life where this planet would be at its best. So 77.1, 97. So obviously its stats are obviously looking very well. So we just need that ice to melt. That ice is still a little too much in there. I mean, it should be able to warm up times 2 it, maybe 15. So that's roughly at Earth conditions now. So can we melt it? Come on, why doesn't the melt button work? Come on. Oh, okay, there you go. But if we click it again, it freezes. So maybe if we melt it and then save the simulation, maybe that will sort it out. So let's just go to 7.0, I guess. Right, let's try that. And then let's reopen the sim. Because I want to get this one all Earth-like before it eventually gets too hot. So, okay, so let's just search it up again. So 7.0. Right, let's give it a try. Come on, please, please do not the ice. We don't want the ice returning. Ah, damn, okay. It doesn't seem like we're going to be able to get it. But at this point, yeah, it is in theory habitable. So, good stuff there. I mean, in theory, what we could do as well, just change the darn ice colour to something else. Snow. Yeah. Let's have it as green. There we go. It's looking more Earth-like now. It does look pretty weird with that, but yeah. Something like that. I mean, you'll see the snow is representing something other than snow. But, I mean, yeah, there you go. So that's at the point where this world... It's at its best. Not got a nice sort of Earth-like blue as well. I guess there you go. So there's this planet in its best sort of condition at the moment. But obviously the star is going to eventually warm it up too much. So let's see how that planet eventually turns out. But at the moment, if we just get a lineup of them all, this one will be the best object for life. What is that going on over here? Oh, that's Fermia. We're in radius. Let's put that back to how it should be. There we go. Right. So we have Orion there, LP12. That one's getting hot. But yeah, Earth-like sitting comfortably as a lifelike world at the moment there, so that's good. How's Blue doing? That's still cold. So everything closer than Earth-like is eventually going to be not in the good spot anymore. Let's see how LP12's doing. Obviously, the closest planet to the star. Looking very, very hot indeed. It's all the volcanic sort of stuff on it there, represented by the city lights. Obviously, that star, though, is going to be getting a lot brighter. Well, it looks like some of the orbits have slightly... the orbits are slightly inclined. Look, I don't remember setting them up like that. I can't remember if I did that, but yeah, it looks like they're inclined there, so... Right, okay, so let's let it roll again. So we'll keep an eye on Earth-like for the time being. But yeah, that's going to get too hot eventually. So let's now let it really roll again. So speed it up. So now we can see 20 degrees. So eventually that's going to upset it. And it's all going to... the water will not be looking too hot. So... Oh, hang, what was that? Oh, that's that world again. So Idle's still trying to hang on in there. Okay, right. I'm very surprised that Oropax is still sitting in there, I have to say that. I thought that would have been gone by now. So the gas giants have almost cleaned everything out. So let's keep it rolling. Let's just get it all going now. Back to Earth-like. Keep an eye on your stats. So 20 degrees. Yeah, that's sitting roughly in its comfortable zone at the moment. So let's see down here. So yeah, the stats are looking good. Then it almost goes up to 99 Earths there. So that's very, very good indeed. Star itself. So this is currently at 4 luminosity. So now let's let the star pass the point where Earth-like will be habitable. So yeah, now it's not going to be working anymore. Too hot. So obviously if we go to it now, it's not going to be looking too good anymore. So if we go to it, obviously we're going to need to re-customize it so it's not looking... All that water's going to evaporate. Also, we can see all the snow stuff's actually disappearing as well. So in theory, maybe it would start to turn more like a Venus-like object where its clouds start getting more Venus-y colour. Cloud colour's white, that's fine. But maybe they'll start to get more toxic. All that water's evaporating, not looking too good anymore. In theory, the water, maybe the water's looking more... Okay, that's not the colour I wanted to customize there. Whoops. So that was the liquid water colour. Oh no, this is the water. Okay, so yeah, in theory, that's probably not going to be looking as good anymore. So let's darken that down, I guess. Ice colour. Just black. I guess we just black out all the ice and snow now. So it's, yeah, it's past its sweet point, and now it's just getting too uninhabitable. So yeah, not looking good there at all. And maybe the greenhouse effect with all that water going into the atmosphere, maybe that would increase the greenhouse on this object. So if we go all the way down here, ATM, maybe that would double up a bit more. Maybe that would increase dramatically. And maybe the albedo, maybe it'd absorb a lot more light. No, reflect more light, but who knows? We have all that extra CO2 and all that evaporated water. That's going to make the atmosphere thicker. So it may get even more hectic than some of the previous objects in here. But yeah, that's not looking too good for this world anymore. So if we look at its stats now, yeah, that life likelihood has gone down dramatically. It's getting too hot here. So Earth-like is now past the sweet spot. So I guess we'd have to... in theory, the trail colour shouldn't be like that anymore. So go for a more... Yeah, that's looking better. Right, so next world out, Sulfur Gas Dwarf. That's now in a fairly sweet spot, 44 degrees there. Next world out from that was Orion. Oh, no, Earth Sulfur Gas Dwarf's closest. Orion's the next object out. So this one is now receiving temperature. Blue, how are you doing? Minus 88, so again, that's our Titan. So we have like a Titan world, then we have a Venus world sort of here. So the Venus world is now, in theory, in its... sweet spot for life, but obviously this one was never designed for life in the first place there. So let's go back to the star. We're going to W up again. So you're going to get... It's getting bigger as well, so looking good. So it's starting to enter that sort of red giant, red supergiant sort of phase. Getting bigger, brighter, more deadly. So yeah, we're eventually going to see the point where poor old Earth-like here is going to be in the 100-degree mark. Yep, so yep, not looking good at all now. So how are we doing? LP12, I'm guessing we're going to start seeing some dramatic increases there, right? So 400, 500. Let's actually go line them all up by temperature, actually. So we can see here, we've got obviously the brown dwarfs, the second hottest. So going down to the planets themselves, so LP12 is still the hottest object, then we have Thermia behind it. Earth-like is the next world, and Orion is catching up with Earth-like for the... it's got more atmosphere, remember, so that's catching up, and obviously there's a big gap between everyone else. So these are the 4 hottest worlds here, and obviously brown dwarf over there. Right, okay. So let's lock back onto our star and continue the process, and we'll start to save it again, because we're evolving further and further into the future here. So go to 8. Let's get that saved. Okay, alrighty, so looking good. That's all saved. Let's continue. Now we're gonna take a big sort of speed increase, let the orbits all sort themselves out as well still. Yeah, we're just gonna keep this rolling. So you see, I'm very, very interested at how Oropax has managed to hold on and keep its orbit retained in those gas giant or ice giant areas. It's in between the Uranus and Neptune sort of equivalent in this system. So I'm very, very surprised that object's managed to hang on, honestly. That is very, very interesting. Looking at the brown dwarf itself over here as well, it looks like it's lost one of its planets, because we had obviously this Neptune world was orbiting it from the start. We had this other world here, but I'm sure there was a fourth one, because we obviously had the one really close to it as well over here. But I'm sure there was a fourth one. This one has a blue atmosphere. Look at this. Maybe this will be a world that could possibly support that life in the future. Oh, wow. I didn't notice. It's got blue atmosphere. It's got ice on it. Just all being waiting to melt, really. Let's lower that albedo. Maybe it'll get some more warmth from that atmosphere as well. Let's give it something comfortable. I mean, it's almost at 1 ATM anyway, so let's give it a little boost. So maybe this world would eventually, once the star gets ridiculously bright, maybe this world will actually be able to be the next lifelike world out in this system. I mean, that would be pretty cool. So if we just have a little land, how are we looking on the surface? So obviously blue atmosphere, still it's still very cold here. So we've got the main star over there in the distance. It's still quite a far distance away from it, to be honest. Then we have our main stars, the brown dwarf over there. Pretty crazy stuff. Obviously if we click play, just won't be able to spot anything. But right, interesting. So we'll give this one a blue trail just so we can keep a note on it for later. So where are we? Interface, yep. Just give it, yeah. So maybe this world could eventually be seeing some sort of Earth-like condition be set up here. Maybe how much water has it got on it? It's got I mean, you can see the ice is on the surface. All that needs is some temperature to warm up. Because obviously the brown dwarf won't be emitting anything. So, yeah, brown dwarf won't be able to support it. So, alright, let's keep it rolling now. So, labels back on as well. Okay, right. So now we'll get into the sort of old systems really evolving now. Because remember, every time we sort of increase the star, we are jumping quite a considerable distance in time when we do that. So, interesting stuff. How's our first gas giant doing here? This one is still, yep, still not getting any temperature from the star, really, so it's still cold. The last of the inner planet's blue here. This one is still cold, like Titan would be. So, there we are. And then I think everyone closest, we have Orion. Yeah, these ones are all in the positive temperatures now. Earth-like is now 105. Fermia, 273. Quite surprised that one's not hotter, to be honest. 87 at Sulfur Gas Dwarf, getting hotter there. And then LP12, hottest planet in here. Being really, really affected by that, right? Okay. I kind of want to make the star bigger as well. Not just light brighter, but let's, again, we're going to increase that luminosity up. So we're going 16, we're going to take a jump to 32 now. See the temperature of the star's decreasing as well. So it's getting older, faster, brighter. Right. There we go. Maybe just make it a little more interesting. We'll give it a slight sort of red tint. Just make it look a little more menacing. So how about something like that? Just make it a little more red sort of looking. Why not? Just make it look cool as well. So we can see, yeah, that red sort of giant face looking pretty nasty stuff. So how's Earth like looking at the moment? So that red starlight will make it look a lot more sort of menacing here. Look at that. It's not looking good. This was the world that was once blue and green, and now look at it. Oh dearie me. I mean, yeah, that's not looking good for this one. Oh dearie dear. Right. So continue. Where's our habitable zone sitting at the moment as well? So we can see the outer solar system, Salby over here. The first of the gas giants is almost getting in that sort of zone. Whoa! Why is the star suddenly moving now? Interesting stuff. Oh no, it's because we had trails on, isn't it? So the star, remember, the main star itself is actually being pulled around a bit, which is interesting. Right. Yes, that main star is moving. Look at that. I never noticed it was doing that. So I'm guessing that's the pull of the brown dwarf or one of the gas giants having an effect on it. Also, if you go back on orbits, you don't notice it. But yeah, the star itself has actually been moving through space as well. So pretty interesting stuff there. Okay, right. And actually what we'll do as well, give it the star itself. Let's give it a red trail now. I mean, it's getting to that hyper, or that, yeah, this will be going to a hypergiant, as one of you guys said in the comments. It's a larger star, so yeah, it could be going into that, or not hypergiant, supergiant. I'm not sure this thing will be large enough for a hypergiant status, but yeah, this thing will be getting pretty big. So if we're going to compare it to supergiants, this thing will be going over about 1 or 2 astronomical units at its highest point. So yeah, we won't make it like stupidly large like Betelgeuse or anything, but I think we could make it fairly large. I mean, let's just compare it to some of the stars. So I think Betelgeuse, for instance, I don't think we're going to make it that big. I mean, that would cover the whole inner solar system. I think maybe, not now, Arcturus. What was one of the other big ones? Antares. Maybe somewhere. Maybe we'll probably peak it around there then. Just maybe a little. Maybe blue. Maybe this one will survive. Well, it's almost at positive temperatures now. Look at that. So that was, yeah, that one's now getting its warm-up point. Right, okay. Right, so let's just keep it going here. But I think overall the system's kind of stabled out now. Apart from our 5th gas giant that hasn't sorted itself out and all these other planets out there, I think everyone else has kind of yeah, they're kind of all sorted in this area. So everything closer than the brown dwarf, his orbit, is fairly comfortable now. So pretty good stuff there. I'm still very surprised that Aurapax has managed to hang on. That is very, very interesting how this one has managed to do that. Very impressive stuff there from that one. Again, let's throw in another save, because obviously we're still advancing time here. So let's do that. Thank you. Okay, so we'll do one more sort of time jump, and then we'll finish off today's episode. And then in the next episode, that will be the finale of this little mini-series of making our custom system here. So again, we're still nowhere near how large this star will eventually get. I mean, if we put it in AU, for instance, yeah, this thing's nowhere near that sort of maximum size yet. So again, what we're going to do is we're going to take another jump. We're going to double it up to 64 luminosity. Now, the star's still getting bigger as well. So that's eventually that. That habitable zone, yeah, the Salby here. Maybe some temperature will be getting received over here now. I mean, that red zone is getting bigger and brighter. I don't think we'll be seeing any action over here yet from our possible next Earth-like candidate. I mean, I don't think this one will be habitable for very long, even if it does get warm enough. But yeah, it is sitting there waiting to go if we do get enough luminosity from the main star. So how's our inner solar system looking at? So LP12, I'm guessing, is going to really... yeah, that does look awesome. Let's just get a look how cool that looks. Wow. So yeah, that one's really, really getting super hot and spicy now. Fermia, again, 500 degrees at Fermia, so that's going to start getting hot. Sulfur gas dwarf was at 200. How's Earth-like doing? Next object out, 229, so not looking good at all there. Orion, this one should be getting some temperature, 226. And then Blue, the last object. Yep, this one's now at 36, 37 degrees. Okay, right. Good stuff there. Let's look back onto the star itself, please. Thank you. Right, good. Let's keep it going. Let's really speed it up now. Let's just really get these objects sort of settled in with these hotter star conditions. So, yes. Okay, so now Aurapax. Actually, speaking of Aurapax, we were talking about how it's surviving. Its orbit is still changing. I mean, maybe it'll make it to the end of this series. Maybe it won't. I mean, it's only got the blue gas giant to really interact with, the Fittiness, and then the blue one here. Yeah, that one there. So it's got two objects it could still, in theory, be ejected by if it gets too close to that brown dwarf as well. Could be saying bye-bye at some point, but I'm still very surprised. It's the last rocky planet to survive in that part of the system here. So there's a close interaction there with the Fittiness. But we'll keep an eye on that one. Okay, right. Again, I think it's time for another star boost. So this is going to go to 120 roughly now, 130. So that's going to really upset some things now, right? It's getting bigger, brighter. Oh, yeah. And colder as well. That star temperature is going to go down, but we can see it's really starting to get nasty now. So let's keep it going. I'm sure Salby should start. Yeah, we can see it's getting warmer. That gas giant. How's Blue doing? Last of the inner solar system, almost in the 100 degrees as well. Earth-like, sulfur gas dwarfs. You can see they're all getting hotter. Fermia. This one, yeah, that's hotter than Venus is now. This one as well. Yeah, LP12, that's not looking good at all. Earth-like, 305, still getting hotter. Interesting stuff indeed there. Aurapax, man, you're really hanging on there with those gas giant orbits. It's a pretty hectic stuff. How are we doing over here? I mean, I'm very surprised that the fifth gas giant over here has still managed to hang on, to be honest. I mean, it has been through a lot of changes. But yeah, maybe it's settled out there for the time being. But its orbit is... No, I don't think it has. That orbit is still just looking ridiculously unstable in there, right? So let's keep it going. So the whole inner solar system is just out of action for anything habitable now. So maybe these gas giants would have had moons, but obviously we've not put them in just for simulation purposes. But maybe one of their moons would be habitable if there was one. So who knows? Let's keep it going now. I mean, yeah, in theory. I mean, I think Akam over here, not that one yet. So maybe moons around Salby will be the next place for life if there is any. I mean, we could add a moon if we wanted, but yeah, it's still not cold enough or warm enough here yet to get into the positive temperatures. So I think any moons of the outer system wouldn't be possible just yet. Let's keep it rolling now. I'm still surprised of how stable the inner solar system was. We can see some of the orbits have changed in there, but yeah, maybe they're all being held together by the bigger objects further out. Not exactly sure, but yeah, that's cool how they managed to hang on there, especially with how large. And don't forget, Fermia is quite a lot, 2.69. So that's quite a large object, this one. So pretty cool stuff there. Right, how are we doing over here? Right. Okay, so they're all just chilling out here. So yeah, this is the main area we're watching now. It's not anything further out. So let's just boost it up a bit. We're kind of running at maximum speed now. Interesting, right. I think, again, back to the star itself. I think we're going to do it again. We'll keep doing it a few more times before we finish up today. So it's going to go from 130 to 260 now, 259. So, plate. It's going to continually upset them. How's Salby doing over here? So this one is almost in that. So... Yeah, almost in the positive temperatures. How much light is this guy reflecting, I wonder? Because I would have thought it would have been warm by now. Let's see here. 51% of light it reflects. Okay, Akam 74. Okay, so this, and that's infrared actually. Never mind. Yeah, okay, 58. So they reflect a fair amount. Okay, so this one's interesting. So if we look at the surface, so we can see there is temperature here. So it is getting it. So how's Saudi doing? 275. Is it tidally locked? Maybe the average temperature isn't really getting up in there. So how slow does this thing rotate? Rotational period 1.45. No, so it's not the fastest rotating object ever. Then Akam is 1. Okay, so these aren't the quickest rotating gas giants. Interesting. The ice giants out here, how are they doing? Well, this one's kind of a mix between gas and ice, actually. Yeah, okay, so that's receiving temperature. How's Aura Pax? This one must be receiving. Okay, so this one's still cold. So it looks like the only planet is. So what about, is this one getting any temperature? Okay, so all of the gas giants are getting temperature in this part, the outer system. So the only stuff that's not getting temperature maybe is the stuff over here still. Yeah, okay, so that one hasn't got any temperature yet. It is warming up, though, if you look at that. Yeah, so it's sitting around minus 150. This one over here, minus 86. And then the world we do want to keep an eye on, down here. So how are we doing? How's this one doing? So minus 106. It's still not, yep, still not warm enough just yet to really get any stuff going on there. But okay, good. Right, so back to the star itself. Okay, let's keep it rolling. I think one more time jump or one more star advance, and then we'll finish off today's video, guys. Otherwise, we'll have nothing to do in the next part, because otherwise we'll just make it too large too quickly. So let's roll it again, and then back to the star itself. I'm thinking, yeah, another double up, going up to 580. So it's really getting big now. So we're at 0.227 AU. So this is, yeah, it's getting pretty nasty. So there you go, right. So let's have one final look of the objects. I think LP12 is just, yeah, it's completely had it at this point. There's nothing left of it. Right, Fermia. You should be fairly, yeah, 1,000 degrees at Fermia now. Okay, right. Sulfur gas dwarf, 500. Earth-like, 513. Orion is at 552. And then blue over here, 199. Gas giant, yeah, even this one, even the gas giant, now its average temperature is almost getting into positive temperatures. So yeah, pretty warm stuff indeed there, right, okay. Fittiness, minus 30, so that's still cold. What about Akam, the biggest gas giant in there? Because that one's still in the minuses for average. Aura Pax orbit still having changes in there. And then over here, I'm not expecting much from these guys yet. I mean, they're almost receiving it. I mean, this one here, it's getting into the minus 20s. And then back to the next possible Earth-like world, I mean, over here. Minus 46. I mean, yeah, next episode, this will be the time where this object finally gets its chance. But yeah, we can see that the star grid is really deadly looking now. So the star itself, I mean, if we just have a look from LP12 itself here, I mean, let's just have a little look down on the surface here. I mean, that's scorching hot. Look at that, right? So looking down on here, our star is, yeah, that's really big. So if we click play, we're just going all over the place. So let's just have a try and actually slow it down. Actually have a nice look at this star as it rises and sets on the horizon. So let's just slow it all down. Let's pause it. Just do it nice and easy. Still going way too quick here. So come on, let's just slow that. There you go. Right. So where is our star? Oh, we can see we're losing material as well. Look, there's a trail. So this planet is not starting to be dissolved. Right. Oh yeah, look at that. So that's it's pretty nasty. So that's sun. This is the sunset on this world at the moment. Oh, we're in the surface. Oh, okay, there you go. So we were actually underneath the surface. So there's your sunset. That's a pretty nasty sunset. That star, pretty hot and spicy, isn't it? So there you go. Obviously, that's going to set. But yeah, that's a deadly one. That is a very deadly one, right? So there we are, guys. That does it for today's video. So yeah, stay tuned for the next period where we go into the red sort of supergiant phase, because that'll be a whopper. Because we know a supergiant doesn't just turn into a planetary nebula like our sun will. This thing's got more mass. This is either going to be a black hole or a pulsar at the end of this, probably after a nova. So this will be interesting. So yeah, guys, make sure you stay tuned for that next week, hopefully, and you have that all said and done. I hope you really enjoyed today's part of this series. And actually, what we'll do is, before we finish up, we're on 10.0 now. So there we go, and then we'll save that, and we'll have a little comparison of where we started and then where we finished off, so we can see, look how clean the orbits look at the moment, right? Apart from the ones far out here. So if we just look at everything up to the brown dwarf, that's looking a lot cleaner than when it was earlier. So if we go back to Go back to the original save we started off. I think it was save number 5. System from scratch. Oh no, we started on 4.0, didn't we? So we started off here. So this is what the system looked like today. So look how much it's cleaned itself out. Look at all these orbits that have disappeared and been ejected. So it's really, really sorted itself out, and that's the sort of evolution I was looking for when making this. And we're very happy it's done that. But yeah, hopefully you guys have enjoyed the evolution of this system as well. So, I mean, yeah, this is really cool the way this is working. I'm in the wrong save, aren't I? I'm going to go to save 10. So where's save 10 gone? There we go. Okay, so 10.0. Yeah, all right, excellent. So, yeah, really hope you guys enjoyed this. And, yeah, if you did, let's see if we can go for 50 likes on today's video for, yeah, part 2 of evolving a solar system to death. As, yeah, we're getting closer to that death. And in the next episode, we will be seeing the ridiculously large star. So, yeah, make sure you, again, like, stay tuned for that. And also subscribe for more helps on the journey to 30,000 subscribers now, guys. And, yeah, also stay tuned for a 20,000 special, because I've still got it in my mind. I haven't forgot, for anyone wondering. So, yeah, with all that said and done now, though, guys, yeah, like I said, hope you enjoyed it. Make sure you guys all have a great day. Stay safe out there, and I'll see you in the next video. Goodbye.